Hi guys, welcome to Budget Power Electrical Solutions. In this video, we are going to understand motor power rating in a simple and practical way. When we see a motor nameplate, we often notice values like kilowatts or horsepower, but many people are not fully clear about what they really mean. So in this lesson, we will clearly understand what kW and HP represent, and why this is important for electricians, students, and apprentices. Power simply tells us how quickly work is being done or energy is being converted. In the case of an electric motor, electrical power comes into the motor from the supply. The motor then converts that electrical energy into mechanical power at the shaft. For a three-phase motor, the electrical input power depends on the supply voltage, current, and power factor. But because no motor is 100% efficient, not all of that input becomes useful shaft power. And this brings us to the two units we commonly see on motors, kW and HP. Kilowatt and horsepower are simply two different units used to express power. 1 kilowatt is 1,000 watts, while horsepower is another commonly used unit for motor power. For conversion, remember this useful relationship. 1 horsepower is approximately 0.746 kilowatts, and 1 kilowatt is approximately 1.341 horsepower. So if we see 7.5 kilowatts and approximately 10 horsepower, they are describing nearly the same motor output power. Now, where do we actually use this power? In industry, motors are everywhere. A conveyor uses motor power to move materials. A pump uses it to move fluids. Fans and blowers move air. Compressors produce compressed air, and machine tools use motor power for cutting and processing. So when we talk about motor power, we're really talking about the motor's ability to perform useful mechanical work. But before we get that mechanical output, we first have to supply electrical power to the motor. Let's look at the electrical input. In this example, we have 415 volts, 14.2 amps, and a power factor of 0.85. For a three-phase motor, we use square root of 3 multiplied by voltage, current, and power factor. Using these values, the electrical input is approximately 8.68 kilowatts. This is the electrical power being taken from the supply. But that doesn't mean the motor delivers 8.68 kilowatts mechanically, because some power is lost inside the motor. So now let's look at the output side. Mechanical output power is the useful power available at the motor shaft. On our example nameplate, the motor is rated at 7.5 kilowatts, or approximately 10 horsepower, at around 1,460 revolutions per minute. From power and speed, we can also calculate shaft torque. For this motor, that comes to approximately 49 Newton meters. One important point here, calculated input and efficiency values are useful for understanding motor operation, but the nameplate rating is the manufacturer's rated output value. So we now have a clear distinction. Electrical power goes in, and useful mechanical power comes out. Now we can connect everything together. Power starts at the electrical supply. It passes through the protection devices, then through the starter, and finally reaches the motor. The motor converts that electrical power into mechanical power, which drives the load. During that conversion, we have losses, including copper losses, core losses, friction, windage, and stray load losses. That's why the mechanical output power is lower than the electrical input power. And the better the motor efficiency, the greater the useful output we get from the electrical energy supplied. So when you're working in the field, this is where everything becomes practical, the motor nameplate. Here, the 7.5 kilowatts or 10 HP value represents the rated mechanical output power. Then we have the supply voltage, rated current, frequency, speed, insulation class, and duty rating. As an electrician, don't look only at the kW value. All of these nameplate values work together when you are selecting the motor, connecting it correctly, setting protection, or troubleshooting a problem. Now let's bring the whole lesson together. The main point to remember is this. When we say motor power rating in kW or HP, we are normally referring to the motor's rated mechanical output power available at the shaft. The electrical input power will be higher because the motor has losses. Also remember the basic conversion. 1 horsepower equals approximately 0.746 kilowatts. And in real applications, always select the motor according to the required load, speed, and duty, not simply by choosing a larger motor. Thank you for watching Budget Power Electrical Solutions. I hope this video gave you a clear and practical understanding of what motor power rating, kW, and horsepower really mean. If this explanation was useful, please like, share, comment, and subscribe to the channel.